Hey guys, so today what I want to do is just work through the practice example that we left off with at the bottom of the notes. So I realized that I did not leave nearly enough room in order to solve this entire problem. So I'll do it on a separate piece of paper, and you can do the same as well. What I did was I went ahead and wrote the reaction here. Okay, I did not balance it, but you can balance it pretty easily there. And also, I just added up the molar masses above each of the compounds. So there's the balanced equation: 1 carbon, 4 oxygens, and 4 hydrogens, and added up the molar masses, so you could have done that on your own. Okay, so the question is, I have 12 grams of oxygen, and I have 14 grams of methane, and they react. Okay? And then I tell you that 4 grams, and that should be 4, it's not 0.4, that's a period, of CO2 is produced. What is the theoretical yield of CO2? So I need to know what is the limiting reactant, what is the excess reactant, and I need to know what the percent yield is. And I also want to know how much excess reactant is left over. So there's a lot of things I need to answer about this question. But before I can do any of that, I have to figure out what the limiting reactant is. So I have to go and figure out of oxygen and methane, which is going to run out first. What am I going to use up first? So to do that, I could choose either product, CO2 or H2O. But I want to work smart, not hard here. And I want to use a little common sense, and I want to choose CO2 as my product, because CO2 is referenced in later problems. I could get the correct answer using water, but I would have to go back and solve for CO2 again eventually anyway. So I want to go ahead and solve for CO2 first. So let's go ahead and set it up. I do 12 grams of O2, and I want to go all the way from grams of O2 to grams of CO2. So I can say grams of O2, moles of O2. So the conversion factor is 32.00. And I go from moles of O2 to moles of CO2. The conversion factor is the mole ratio, so I put a 2 there and then a 1 there, because there is just a 1 right there. And I go from moles of CO2 to grams of CO2. The molar mass of CO2 is 44.01. I get a 1 there. Okay, so I'll go ahead and I'll do the math in just a second, but I want to go ahead and set up the second part of this calculation. So I also, let me fold this, keep it on the screen. So now I also need to look at the other reactant. So I have 12 grams CH4, and I want to go through and do the exact same calculation. And so I have grams of CH4, moles of CH4. My conversion factor to go from grams to moles, as you know, is the molar mass. So the molar mass of CH4 is 16.05 grams per mole. Then I go from moles of CH4 to moles of CO2. I use the mole ratio. There is a 1 there and a 1 there. And I go from moles of CO2 to grams of CO2. I get 44.01 and 1. So before I do the calculations, I want to go through and make sure the units cancel. Grams of oxygen, moles of O2, moles of CO2, I'm left with grams of CO2. Grams of methane, moles of methane, moles of CO2, I'm left with grams of CO2, so I'm in pretty good shape there. So now in the calculator I can type in 12 times 44.01 divided by 2 divided by 32, and by this point you've probably developed a method to type in the calculator, so do it however you prefer. So I just need 2 significant digits here because I only have 2 in the problem. So my yield here is 8.3 grams CO2, and I want to go back and double check myself. So 12 times 44.01 divided by 32, and again I get 8.3, so I'm in good shape. Then do the bottom calculation, so 12 times 44.01 divided by 16.05, and I get 32.9. So again, I want to go back and double check myself, make sure I didn't mess up. So 12 times 44.01 divided by 16.05, and I get 32.9. Okay, so we have 32.9 grams of CO2. Okay, so we see here that if oxygen runs out versus if methane runs out, there are very different answers. Okay, so based on the amount of oxygen, I can produce this much CO2. Based on the amount of methane, I can produce this much CO2. So it should be pretty obvious here what my theoretical yield is. The theoretical yield is the smallest of these two numbers. So my theoretical yield is 8.3 grams of CO2. So that is my answer to A. I can also go ahead and label O2 as my limiting reactant. So O2 is limiting, CH4 is excess. So I could reword that and ask you, what am I going to run out of first? I'm going to run out of oxygen first. Oxygen would be the reactant that is consumed completely in the reaction, and there is some methane left over. Okay, so to answer part B, I want to know what is the amount of excess reactant left over. So what I'm really asking is, initially, how much CH4 do I really need? Okay, so I can write that down. How much CH4 do I need? I know how much CH4 I have, and if I know how much I really need, I can know how much is left over. So there's really two options here to solve this problem. I know that I'm going to make 8.3 grams of CO2. So I can go from 8.3 grams of CO2, and I can convert that to grams of CH4. So the question in words that goes along with that is, in order to produce 8.3 grams of CO2, how much CH4 do I need? I also know that I'm going to completely use up 12 grams of oxygen. So I can say 12 grams of O2. I could convert that to grams of CH4. So the question I'm asking here is, in order to use up 12 grams of oxygen, how much CH4 do I need? So you can do either one of these. So we'll go through them both just to kind of do as a proof here, but either way you'll get the number that you need. So let's go ahead and set it up. So the first one, I can do 8.3 grams of CO2. And if I were you, I'd go ahead and pause the video and try this on your own, and I'll just work through it quietly, and you can check your work when you're done. So there are the units set up, and I can go ahead and plug in the numbers there. The molar mass of CO2 is 44.01, and I have 1 mole. The molar mass of oxygen is 32.00, and I have 1 mole there, 1 mole there. The molar mass of methane is 16.05. Then I get my mole ratios. So from the balanced equation, the coefficient for methane was 1. The coefficient for CO2 was 1. The coefficient for O2 was 2. So now I can go back and do the math. So let's do 8.3 times 16.05 divided by 44.01. So I get 3, and I'll write down all the numbers just for reference. 0, let's write that down. 3.03, but I really just need 2 significant digits from the problem, so I can just say 3.0 grams CH4. And I can plug in and check the second answer, the second equation. 12 times 16.05 divided by 32. divided by 2, and you get the same answer. You get 3.0 grams of CH4. This is kind of a proof. No matter which method you choose to do, you'll get the same answer. You will get that you need 3.0 grams of CH4. So I can write this as need. Okay. So now I didn't ask you how much you needed. I asked you how much was left over, how much is in excess. So I gave you 12 grams. So 12 grams minus 3.0 grams. So I gave you 12. You need 3.0. How much is left over? So that is just 9 grams of CH4 remaining. So after it's all said and done, we use up all the oxygen and we have 9 grams of CH4 left over. So now the last question is, what is the percent yield? So I know percent yield equals actual divided by theoretical times 100. So I can plug that in. The actual yield is from the lab. That's how much we actually get is 4. The theoretical yield is the number from here, 8.3 grams times 100. So I'm plugging the calculator. 4 divided by 8.3 times 100, and I get 48.2, and we can just round the percentage to one number after the decimal. So our percent yield is 48.2%. Okay. So let's go back and think about what all I know now. Let's just label the facts that I've learned. I know that based on this situation, I'm going to run out of O2. I'm going to produce 8.3 grams of CO2. I'm going to use up 3 grams of CH4. I'm going to have 9 grams of CH4 left over. And based on the actual yield, my percent yield is 48.2%. Okay? So the calculations are somewhat complicated if you look at it all together. But break it down, look at it step by step, and think about for each step what you're really trying to accomplish. Because essentially it all boils down to converting from one unit to another, then thinking about how much product can I make, and how much of the reactants do I actually have left over.